conversion. Y'all ready? This is where we're fixing to get into unit circles. It's going to be so much fun, but not today.
Okay, wait, what do we have to do in that project, and why can't we do a video?
The project's soon. They'll probably be next week.
How long do we have?
Unit circle project. And we'll spend some time in class working on it. Because just because I have kids, and I hate it when they get these projects that they have to come home spending all this time on. So I like to take time in class. But it's like the candy and the little Captain America thing, all those are unit circles.
Oh, that's fun.
The record, the egg, the guitar, the orange slice, the snail, the ladybug. Yeah, on the other side. The bicycle tire, that was wins. Yeah. The stoplight, they're all those are unit circles. The donut and the photographer.
I like the dime.
Yeah, the dime.
Oh, where's the bottom right?
It is a project. The one that's painted, the little one is. The big one, I think she hung that up on the wrong side. Kenzie, whenever she was hanging up all my posters and stuff, because she didn't know what it was. The record. There's a bowl of soup over there on the radiator. The Knights of the Round Table. That's one. Somebody did a pumpkin pie one year. Yeah, the clock. That was Hope's. That's not a unit circle though. Just a clock. Drums. There's some drums up on top of mine. That was cool. It's cool. It's a fun little project. All right, let's talk about an angle conversion. How many degrees does a circle have? 360 degrees. Here's what I'm going to do. I'm going to put it on an XY plane. Okay? We're not talking about functions right now, but you are correct. From here, having one side, the x-axis, this is one ray that makes up my angle. I am going to call it the initial side. As I loop around to some other side, we will call this the terminal side. My angle is measured from the x-axis to this point here, and we refer to this as theta. Theta is going to be the new variable that we use to indicate angle measure. Theta. Theta, theta.
What is that?
It indicates angle measure. It's what we use most often. I can go forwards that way, which would be counterclockwise. That would give me a positive theta. I could go the other way. That's exactly right. Starting here, again, my initial side is the x-axis, and coming this way, this would be, my theta here would be negative. So if I'm looking, and we'll just do some easy ones to start with, I could call this negative 90 degrees. Right. Okay, I might have said it backwards. The green is positive, the pink is negative. Okay. But what happens is I could actually name this, I can have what we call coterminal angles, okay? Which means, now y'all stay with me for just a second. Coterminal. Whew. I appreciate it. I appreciate it. If I asked you to graph, I'm fixing to show you. Give me a second. Let's say I asked you to draw or sketch an angle that was 45 degrees on this circle. Using this as your initial side, where would your terminal side end up? In the middle right here. This is about, because this is 90, right? So half of that is 45. So this looks like theta might be about 45 degrees. Do you agree? Now, we're not even doing that yet. Is there another theta value that would give me the same terminal side? Sonny, what you got? You're going in radians. We haven't learned radians yet, but yes, but give it to me in degrees, not radians. How'd you get that? If I go from here to here, that's 45, right? I could loop all the way back around another 360 and end up back where I was. Coterminal. Okay, yes. Would what? Yes. I could keep doing this an infinite number of times, and these angles are what we call coterminal because I'm just adding 360 every single time, okay? So coterminal. Okay, those are all coterminal. I can also go the other way because I can measure angles negatively. So tell me what the first coterminal negative angle is to 45 degrees. Why? And if I went backwards, if I started the same place, but I went backwards 315 degrees, right? It's still the same, it's still a coterminal. Well, then I'm going to start going backwards 360. Well, because if I do 45 minus 360, I get negative 350. So you can add or subtract 360 an infinite number of times. Is everybody okay? Okay. Yes. This is what it's going to look like. Sullivan, come sketch an angle in standard form, which means that I start at 0. Approximately negative 140 degrees. Negative 140. Negative 140.
Hold on, let me discuss here.
Negative 140.
Well, I know this is gonna be. It's gonna go this
Draw
way.
the ray.
Okay.
Doesn't have to be exact. Just
Hold on, let me think.
you don't have. I was just using that to show you how many degrees are in it. Is she right or wrong? Negative 140. Guys, I need you to pay attention. Is she right or wrong? Negative 140.
Yes.
Yeah. What?
No. It would be on top. It would be in the third quadrant.
Tell me.
Corey says you're right.
Okay, I'll trust Corey with my life.
How Yeah. How many degrees is each click around the quadrant?
90.
90, right? All right, this is 90, this is 180, this is 270, this is 360, right?
What?
Yeah, for those.
I thought it went.
That's if I'm going positive,
Okay.
right? So I need to go backwards. There's negative 90. If I make it here, that's negative 180. So I need to be, so I would say, yeah, other than her being, maybe I'd get a little bit closer to,
Well, it's not gonna be perfect, bro.
but it's not going to be perfect, but yeah, I agree. Closer to 180. Maybe somewhere around here. But yes, that's all we're doing right now. Right. Yeah. Yeah. Thank you. You are a good sport. Hey. All right, let's do the good stuff. Once we get to this point, I'm at 10 minutes where everybody was paying attention, nobody was talking. But see those boys back there? They've been steady scouting and haven't been paying attention to anything. So I can't even start my time yet.
We're listening. I'm listening at least.
We're continuing on. I'm just at degrees. Somebody said degrees. Degrees are for babies. We're not going to do degrees. Well, we'll do them a little while, but then we'll get out of the degrees altogether. Instead, what? Yeah, for right now, but I'm fixing to show you another way. Another way we measure angles, which is what we do after we get out of this unit. We'll do some with degrees, but from this point forward, we'll be all out of degrees. And we use what is called radians to measure degrees. To measure angles, okay? So let me show you what these look like. Charlie, shut your mouth. An entire circle. What? Probably. Okay, whatever. It is. Y'all are being extra. Okay. An entire circle has how many degrees? 360 degrees. In radians, 2 pi. Which means, yeah, 2 pi is a radians. Yes. Which means, I'm sorry, we hadn't gotten there yet. Yes. Because they're not pies, they're radians. I don't know. Okay. Halfway around the circle, how many degrees am I in? 180 degrees. How many radians do you think that is? Pi. Pi radians. Up top, 90 degrees, which is how many radians? A half of pi radians. You're exactly right. So pi over 2 radians. Down at the bottom, 270 degrees. How many? 3 pi over 2. 1.5 pi radians. Okay? Now, we won't get into, these are the first little bits of the unit circle, but we won't get into all that today. right now we're going to look at converting degrees to radians and radians to degrees, okay, and practice with that because that's going to help us derive the unit circle. And that's all we're doing today. All right. Y'all remember unit analysis? Y'all never did that? So if I'm in degrees, then if I multiply by something that equals 1, but it's radians over degrees, essentially the degrees cancel out, leave me with a unit of radians. It is chemistry. Well, it's not. It's actually math that's in chemistry, but you do it in chemistry. All right. If you don't understand that, it's okay. What we're going to do to go from degrees to radians. So I'm starting in degrees, right? Say I have 37 degrees and I want to know how many radians that is, okay? I'm going to multiply by pi over 180 every single time. I was just saying any example that you have. It's an irrational number. And you have to leave your answers with pi in them. Radians should always have the pi's. Now listen. Why does this work? Why can I multiply by that and it keep the same value? Pi radians and 180 degrees are the same value. What happens when you divide something by itself? 1. What happens when you multiply something by 1? It stays the same, so it keeps its same value. So let's say I had, and let's just look at the unit circle and see if it works. Using this conversion, convert 90 degrees to radians. Mark, set, go. Using the conversion I gave you, not a number, an exact, leave the pi in it. No, I'm just showing you here. Look at your circle, and that makes sense that it works, right? Oh my goodness, I'm trying so hard.
It makes sense to Charlie.
Why can't you just draw on a calculator?
Okay, let's see if you understand.
Are we supposed to do it like that, or can we do it on here?
Well, that doesn't keep pi in
Okay, but you could just do 90 divided by 180, math, enter, and throw a pi at top. Give me, don't blurt this out whenever you get it. Give me a coterminal angle in radians to this value. Don't say it out loud. I don't even know what you're saying right now. We've only done coterminal in degrees. We haven't done it in radians. But it's the same thought process. How many radians does it take to loop all the way around one time? In radians. How many radians? No. 2 pi. Look, looped all the way around. How many does it take? 2 pi's. So I just take this and I add 2 pi to it. Well, how do you add pi over 2 plus 2 pi? I give up. I'm listening.
Whoa, that's 4 pi squared. Oh.
Oh dear.
I told you it's 4.
That's not 4, bro. That's 5 pi over 2.
Just add the 9. That's what you just said. I like my way. I'm doing it right. You said that's how we're supposed to.
Wait, no, go back. I'm not done.
We can use our angle coach. No, I'm talking about. Like, can we not do that? So what I did was
Can we take a lap?
you said we started 90. So you add the 90 to the 360.
You added it to the original degrees, and then you converted back over?
I had 90, and then I added the 360.
Okay. You're just doing a double conversion, but that's okay.
That's what I was saying.
I don't even know. Do this one. Convert it to radians. And then give me a coterminal angle in radians. Loop around the circle. Add 2 pi. If it's in radians, coterminal means if it's in radians, add 2 pi or subtract 2 pi. If it's in degrees, add or subtract 360. It just means that if you loop all the way around, you'll end back up in the same spot. Yep. Now if I do coterminal 73 pi over 180 plus 2 pi. Okay. Now your unit circle test will be non-calculator. But for right now, for these, they're not angles like this on your unit circle. These are just random angles that I'm giving you. So for this one, I'm probably just taking this fraction, adding 2, and then hitting math, enter, enter. 73 over 180 plus 2, and then math, enter, enter. I did not anticipate this being hard. Okay, you got it right now. Until you get used to converting these, you got it right now. You would have to go through and find 73 pi over 180 plus 2 pi, find a common denominator, 180. And combine the tops. You won't have anything like that, no, not even on unit circle. On the unit circle, like 210 maybe, or 325. You'll memorize. We'll get to that later. me the angle in these directions are a little bit different. Give me the angle in radians, and then give me one positive and one negative coterminal angle to it. Again in radians. Convert it to radians, and give me a positive and a negative coterminal angle. The first time we've done something brand new, and y'all are like, I'm telling you, what is going on? I could only imagine. Charlie, what am I going to multiply by to get this thing in radians? He is wrong. Pi over 180. That's a coterminal. Right now, I need to get it in radians. Convert it to radians. Give me a positive and a negative coterminal. All right.
Okay, so a coterminal is 2 times the terminal of 1. I don't know.
Okay. This is degree to radian. Okay, let's get straight. All right. So what do you get here? What's 15?
Why did you put 2 before the pi?
Thank you. Now, coterminal. Coterminal means in radians, add or subtract 2 pi. In degrees, add or subtract 180. Oh, 46. Okay, that's how we find coterminal every single time. I would be here, but you can do whichever you want. Yeah. Yes. Yes.
How did you get 12? 180 divided by 15.
All right, so for the positive, look, pi over 12, since that's radians, I'm going to add 2 pi.
No, but how did you get pi over 12?
I multiplied by pi over 180.
Looks like 15 times 180.
Divided by 180.
Okay.
So, yes, 25 pi over 12. And then if I subtract 2 pi, okay, there's my 2 coterminals. Now, Charlie, you are distracting me.
Minus 2 pi. What are we doing?
Just don't listen to me, Slade.
She said find a positive and negative answer. Obviously.
Hold on, let me write this down. Okay, so the top of it going from degree to radical, the bottom is going to radical coterminal.
This is like a part A and part B. Part A, convert the degree measure to radians.
Yes, and you did that.
Part B, find both a positive and a negative coterminal angle. Yep. And you need a
I'll think it like you just like a bottom.
So you need to pay attention really bad. So I multiplied by 12 on the top and the bottom. 24 more.
No, you're not. Plus 1 is 25 pi.
Can I work on board?
What about the in degrees part? We don't have to do that. There's things that
I think y'all are very complicated.
If you can butterfly that, you can.
Why is the national butterfly?
You can butterfly that. They're making butterflies. I don't like it.
That's her, like,
You want steps?
Now you do the opposite. That's what I'm saying.
They're cackling over there. Alright, calculators work here. I need help. Calculators don't work. So,
There you go. That's the closest thing to steps I can give you for this.
Oh, wait, you play
oh.
All right.
Oh, you must have. Oh, I need to.
Exact only, which means I'm going to need to do math enter.
360 over 7. So it's 360 over 7 degrees.
So I got 2 pi over 7, and I'm going to multiply by 180 over pi. And it should put me back in degrees, right?
Wait, we have to make it we don't have to make it over.
The pi's go away.
Oh, we can do that. That's the high. That should be standing on 360 over 7. I like that.
I'm probably coming up.
Give me 2 coterminals to that. This time I'm in degrees, so what am I adding and subtracting? 360. So 360 over 7 plus 360, and 360 over 7 minus 360. Use your calculator. We'll start passing those around. This has been like pulling you by your toenails. Is it bad? Ellen, no. Make sure you put the degree. Some of you are going to miss that point on your quiz and you're going to be very mad at me, and I'm not going to have any sympathy because you're not listening. You heard me say it though, right? Okay. So nobody can say I didn't say it, and it's in the recording.
Nothing. She's not repeating herself. You get the